Um, it is 1 o'clock, and this talk is pretty much exactly 40 minutes, so we're going to get started and just let people trickle in as soon as they're able to finish up with lunch downstairs. My name is Tim Bach. I am a product security engineer at Salesforce right across the street, so it was a pretty long trip for me to get here. I focus in my job on penetration testing of our independent software vendors and partners on our AppExchange, and I will get into a quick review of what the AppExchange is in a couple of slides. But the other part of what I do in my job, and mostly what we're talking about here, is security research and development, specifically focusing on automation to try and make security easier for the general cloud community and for people that might not have the resources to have a large product security team. So at Salesforce, and specifically myself, we're pretty passionate about making those tools accessible to as many people as possible and maximizing our impact. So today, we're going to talk about a tool that I've been working on for about the last year and that we are calling Chimera when we release it to our independent software vendors and our app ecosystem in a couple of weeks. But what is it? Why are we talking about it? Chimera is a security scanner based in the cloud. It's massively scalable, and it's made up of some of the best open source security tools that are out there right now. And we're handling all the infrastructure of it. We wrote a lot of code to consolidate all these tools, to make them usable to a lot of people, and to manage the scalability of it. So the core engine of Chimera is ZAP. As you might expect at an OWASP conference, we're talking about why we are using ZAP and how you can make it available to so many people and why that's important. We've also used some industry standard tools like Nmap and Nikto, and quite a bit of custom code and some custom tools that we've put together. That's kind of what ties it all together. And we're giving all this out for free to our independent software vendor community, and we think that's really important. I'm going to spend some time talking about why that's important, and then we're going to be actively looking for even more ways to give back to the open source community, especially OWASP. So we will talk about all the technical background of this, all the nuts and bolts of it, and some really cool technical work that we've done. But before we get into that, there is something important that I think as a security community it's worth talking about. And that is why. Why do we care about putting a security scanner in the cloud? What advantage does that have over just running it locally? And kind of more specifically, I am a security engineer at Salesforce. Traditionally, being on the product security team at Salesforce, my job would be to look at Salesforce code, look at the code that our R&D engineers write, and focus on securing our platform. And we have a pretty large security team, so why are we dedicating a year's worth of security engineering time to building this tool? What advantage does that have for us, and why is it worth the effort? So we're talking about scalable security, we're talking about security affecting a lot of people. Obviously, we're talking about the cloud today, but specifically I want to talk about one part of the cloud that's becoming more and more ubiquitous, and that's a cloud app ecosystem. It's a term that many of you are probably familiar with or have at least heard, but I do want to get on the same page about what we're talking about. So a cloud app ecosystem, in my book, is attached to a cloud platform. So it's not something that's standalone. It's something that's an addition to something much more than itself. The apps in this ecosystem expand the platform that they're based on. They're doing something novel. They're doing something the platform itself doesn't do. They're enhancing and they're extending the platform, probably in ways that the original developers of that platform never thought possible. If any of you were at the keynote this morning, they were talking about, as security engineers, we have to think about what our tools and our platforms and our products are going to be used for, not just the core use that we built it for, but what they're going to be used for in the wild. So apps in a cloud app ecosystem, they may be web-based, they may be mobile-based, they may be client-based, but they probably call out or in from or to another web app or another service, and that's probably a big part of how they're extending the platform that they are built on. So essentially, you have a lot of third-party developers expanding the platform in ways that the original developers of the platform didn't think of, didn't bother to do, weren't focused on. And as security engineers, you might not have been focused on these uses either if you're doing the traditional product security model of looking at what your developers write. The really important thing to think about, though, is that apps within a cloud ecosystem are granted access to the platform data. So these apps aren't just running on the platform, they're actually integrating with the platform. They're granted access to data that users of the platform put on the platform. So now we have apps written by third-party developers who don't work for you, and you as a product security team don't work with them, probably. And they're being given access to data that was entrusted to your platform. And it's seamless. So if you're looking at an app on a platform, you don't necessarily know where the platform ends and where the app begins. Where is that line drawn, right? So who is responsible for ensuring the security of the cloud app ecosystem? Who is responsible for ensuring the security of the data that was trusted to the platform and is now being shared with the app? So in the marketplace today, we have some mobile ecosystems with millions of apps. I didn't go through and do any data analysis of which of those apps or how many of them actually do something other than put an icon on your home screen, but let's assume that there are several. And the mobile app ecosystems that are prevalent in the market today have review processes focusing on content, on library usage, on best practice guidelines. I'm assuming that a lot of them do automated malware scanning. Some of them probably do some cool static analysis. We do have some pretty smart companies managing these ecosystems, right? But there are millions of apps, and there is a product security team of tens of people probably, right? So now these platform providers have to balance the volume of their app marketplace with their security controls, and that's a major challenge. And I think if you've been reading the news over the past couple of years, you've seen evidence of how much of a challenge that is. We also have social platform ecosystems with thousands of apps or tens of thousands of apps. And those apps, as you might expect, are granted access to user data on the platform. They're granted access to your social graphs. And that's all some information that's pretty useful for phishing. And again, the review processes in those marketplaces usually focus on content and use of API, intellectual property, trademark violations. But those apps can still access all this user data and send it to other services in the background. And keep in mind that users of mobile ecosystems, users of social platforms, these users are not necessarily software developers. They're not necessarily security engineers. We're talking about technical lay people. And at its core, product security's function is to protect those lay people, right? We are educated in software security. We know what's going on. We can't expect a technical layperson to know what's going on, and it's our job to keep them and their data secure. So I'm going to talk about my personal favorite app ecosystem, and that's the Salesforce App Exchange. That's the team that I work with to secure. And we have about 3,000 applications. I haven't pulled the numbers recently, but when I wrote these slides, it was just over 2,800, so I'm guessing we're close to 3,000 now. Most of them do integrate with external systems, just like consumer app marketplaces. We've had 3.25, probably close to 3.5 now, million app installs, so the apps are widely used. They're hitting a lot of customers. But where we are in the minority, and maybe unique, is that we do full penetration testing of all App Exchange listings. So if you want to be listed in our app marketplace, you have to go through our team, and we're going to do a full scope penetration test. And we're not just going to do it on the code that you put on our platform. The services you call out to are also in scope. So that means that we are doing full scope penetration testing on every service that your data could possibly travel through our platform, through our app marketplace and ecosystem, and get to. And essentially what we're going to talk about for a little while is why that's important and some of the lessons that we've learned along the way. Because we have been doing this for quite a while. We have done thousands of full scope penetration tests, and we've worked with our partners and our independent software vendors through this process, and so we have a little bit of perspective on what it means to them and what it's like for a product security team to be doing this. So, why secure the ecosystem? I'm going to go back to that question that I started with. Why bother? Why put thousands upon thousands upon thousands of security engineering hours into these penetration tests? This chain is protecting your data. Behind the fence is all the data that you've put into the platform, whatever platform you want to talk about that has an app ecosystem. Behind that fence is your data. All of your users' data. Everyone that is using your platform, your revenue stream. All of that is protected here. And this lock right here is what you're doing as a traditional product security team. You are focusing on the platform most likely. I'm making some assumptions based on the traditional product security model, but I think they're fairly safe assumptions. The vast majority, if not all, of your product security resources and budget and man hours are going into securing the platform. They're going into securing what your engineers write. That's the code you're caring about right now. On the other hand, most, if not all, of the same data that is entrusted to your platform is accessible to your app ecosystem. Who's spending the resources to protect those vectors into your data? And who is responsible for it? And does it matter who is responsible? As I said earlier, I think we're one of the few exceptions to this view, and if you get nothing else from this talk and none of the technical details, I want you to think about whether that's the right model. Why secure the ecosystem? It's because we want to encourage a thriving development ecosystem. We want to ensure a thriving development platform. But most importantly, it's because we want to maintain trust in our platform as a whole. That's why we care. So I want you to think about this scenario from the view of a technical layperson, from the view of somebody who doesn't do software development, they don't do security development, and their last interaction with secure code was using the forgot password flow. Okay? So they put their data into your platform, the platform that you built, the platform that your company relies on being used. So then they install an app from your app marketplace that shares that data with an external system. I can't think of an example off the top of my head, and I don't want to name any companies' names to make an example, so let's just say it's a theoretical app that's sharing data with another system out on the internet somewhere. That external system is breached, which is, it's happening every day. Some new company is breached. So that external system is breached, and now data that was placed in your platform is stolen. You were never breached. Your platform is secure. Your product security team did their job. Nothing on your platform is vulnerable, which is probably not true, but let's assume. The customer sees the data that was placed in your platform on Pastebin. Okay? They see their username, their password, the home address, the last 4 digits of their social, their mother's maiden name, whatever. It's on Pastebin. All they know, right? All they know is they put their data in your platform, and now it's public. So they trusted your platform with their data. They used your app marketplace, and now their data is stolen. Do you really think that a technical layperson is going to see the distinction between the app's security team and your security team? Or, much more likely, do you think they're just going to stop using your platform? Do you think the media is going to see the distinction? I don't think so. The status quo, what we're looking at right now. We do about 1,800 security tests a year, and we found that the enterprise web vulnerability landscape pretty much mirrors the consumer web. Which might be surprising to you, might not, but you think about it's basically the same developers developing these apps. So our most common findings, cross-site scripting makes up 20% of our findings. All the vulnerabilities we found, not just 20% of tests include XSS. Information disclosure, about 11%. Various types of CSRF, about 6%. The average listing that we look at undergoes 2 rounds of penetration testing. The average right now is 1.95 to pass. And all of our tests are full scope, full breadth, but they're fairly shallow. So what I mean by that is that if you fail the first penetration test and you come back for round 2, we're not just verifying remediation. We actually are making sure that you have everything secure. So we're looking at regression. We're doing basically from square zero. And we spend 8 to 16 man hours per test, so we're not going to find every instance of XSS. Our reports are very clearly laid out so that you understand we found 1 or 2 instances of every class of vulnerability, and now you're going to go back and hopefully look through your code and fix it. But what we've eventually come to realize is that it's important that we spend a lot of our product security resources helping people and not hacking people. So we spend a lot of our time teaching smaller companies, smaller dev shops, our ISVs, we teach them security, and more than that, we're trying to get buy-in that security is important. Because if you don't get buy-in that security is important, then what's going to happen is, well, they go through the penetration testing, they're going to fix what you find, and maybe they're totally secure, or at least mostly secure when you eventually pass them, okay? But then 3 months later, they push out version 1.1, and every mistake was made again. If you don't get them to understand why security is important, you haven't accomplished anything. So if any of you have done consulting or worked on penetration tests for clients before, or maybe just worked with your own engineers before, you might be familiar with a phenomenon that we call the 5 stages of security grief, which is you start out the conversation with the engineer saying that it's not a problem or it's not in scope, And by the end of the conversation, hopefully you've gotten them to the point of where they're saying that they can fix these bugs. But you usually go through a couple stages, right? We're on a deadline, we can't fix this. How can you expect us to fix this? And then maybe if we fix the P0s, you'll leave us alone with the P1s, right? So it's important to have this conversation and again get buy-in. You want to walk them through the issues and you want to explain to them why the issues are important, and then you want to get them to agree to fix those issues and agree to care about security. So that's our goal. And one of the ways that we did this from the start is we have tons of resources that we give our partners at the very beginning of the process. So you see up here, if you're in the front row, if you're in the back row, what you should be seeing is that we have a lot of links to the OWASP top 10. We have a lot of links to the OWASP design guides. We have a lot of tools that we developed, like secure coding analysis tools, freeze static analysis. So we try and start from the beginning, right? We try and set these expectations from the beginning. And we try and teach them how to do security right. And that's what we use a lot of the OWASP documentation for, because that's what this open source community is great for, compiling this documentation. There's no reason that every developer shouldn't be reading the OWASP top 10 before they start a project on the web. But we realized that we need to expand our impact. We simply don't have the resources to have enough product security engineers to do this for everyone. So that's where Chimera comes in. It's basically a force multiplier for us. On average, we have 4 full-time heads across 8 people, maybe half-time, but we have 4 full-time heads working on penetration testing if we're lucky. Now it takes about 2 tests to pass. Let's say there are 850 new apps in a year. We do the periodic re-reviews. We look at them once a year just to make sure they're staying secure. So if we can come up with automation and cool tools that bring the number of tests it takes to pass down to 1.5, well, now we've saved 380 at least penetration tests, and we've freed up basically a year of a full-time product security engineer's time. And we can do some really cool things with basically another head in our year, right? And we're going to talk about some of the really cool things I think we can do and that we're talking about doing a little later. But let's get into ZAP. Let's get into the technical parts of it and why we're doing and how we're doing security scanning from the cloud with ZAP. So our goal is this, right? And this is not a slight against ZAP. It's not a slight against NICTO or Nmap or any other security tool. I use them all when I do penetration tests, and I love them. I use them from the command line. You have all the control in the world. If you are a non-security focused engineer, or if you're a product manager, you don't know how to use these tools from the command line, and you might not even want to spend time to learn how to set up ZAP. ZAP's user interface has made massive amounts of progress over the last couple of years, and I still don't think you could convince a project manager or a dev who has a lot of other priorities and isn't security focused to sit down and learn how to do it. At least not easily, right? So we want to, while we're trying to get buy-in and while we're trying to get them to learn these things, we want to make it as easy as possible, right? We want to make it so it's fire and forget. So the flow that we want from a user of Chimera is that they log into Chimera, and we're going to use an authentication system that they're already familiar with. So we call them publisher credentials. These are the credentials they have to list their product on the App Exchange. So you could use it, Apple ID for the App Store, or your Google account for the Play Store, many examples, but use credentials that they already know. Don't make them set up something new. They enter a URL to target, and optionally they enter test credentials if we want to do an authenticated scan. They validate ownership of the target, and the way we're handling that is giving them a token that they have to upload, and we just verify that the token is there. So we're verifying that they're not using our tool as a weapons platform. And that's it. That's all they have to do. And then they receive a notification email when the scan is done. They download it, and they're given a PDF or an HTML file with very actionable results, something that you can take back to your team and say, we need to fix these things. We need to look for these design patterns. And it's not just technical gibberish. It's actually actionable. So very quickly, I'm going to jump out and do a quick demo of what that looks like. So right here, you have the login to the portal. All you have to do is hit login, and these are credentials that they would already have. And hopefully the Wi-Fi is still pretty solid. It looks like we're going to get in. All right. Now all you have to do is hit new scan, and let me try and zoom in a little bit here. Okay. So all you have to do is hit new scan, type in your target. So we're going to use demo.testfire, which is one of the sites that we use for security tool testing. This do not scan list is if you have any pages you really don't want us to hit with automated scanning, if they're destructive and you're worried about them, you can give us a list of do not test pages and we will respect that, though obviously we recommend that that list is as short as possible. And then you would just type in a username and a password. And what this does, one of the pieces of code that we built internally is a Phantom.js-based automatic credential login system. So it's going to spider the site and try to find the login page. It's going to try and successfully log in with these credentials. It's going to identify which pages log you out, and it's going to pass all of that back to Chimera. So Chimera will have an authenticated cookie jar to give to ZAP, so that ZAP can scan the entirety of your application, and it will have a list of URLs it shouldn't hit so that you don't log back out. And this is something, if you're using ZAP manually, you all probably have used before, that function. So we're just trying to automate that. It's not perfect. It turns out it's pretty hard to find all the different ways you can log into a website, but we are always working on it, and we're going to start to play around with full headless browsers instead of Phantom.js in the near future. So then all you need to do is hit submit scan, and you would be done. Then you would be able to wait for the result to come into you. And you see here, you can come back and check the status. If you were done later on, all you would have to do is come up here and then hit download results. So let me jump back into PowerPoint. All right. So now you've seen the customer-facing side of it. You've seen how easy we want to make it. But being, as you are all security engineers or software engineers, let's talk about how we're doing it. Let's talk about the really interesting part of this, which is the nuts and bolts, the technical side of it. So at its core, we have four major components. We have the scanners, and that's ZAP, Nikto, Nmap, and a few others that are internally written. We have Heroku, which is handling all of our scalability. Heroku is basically our DevOps team, so that no one on my team, and certainly not me, has to sit around and do DevOps because I like to take vacations every now and then. We have a persistent data store, and we have a cache. We're using a Salesforce backing org, and we're using Redis, and I will explain why we're not using a more traditional database. And then we have a bunch of custom code that we've written to manage everything and pull it all together. So as I mentioned, ZAP is our flagship. That's what makes most of it tick. That's what we expect our partners to use. If they're not using Chimera, we tell them to download ZAP, give us a report. But then we also use Nikto, which is another web application security scanner. It's going to find common vulnerabilities, known misconfigurations. By default, we scan ports 80 and 443. And then we have Nmap for port discovery. We actually pass every port we find on Nmap outside of those two back to Nikto, just in case there's something that Nikto can find on those ports. We have SSLIs to detect SSL issues and server misconfigurations. And then we have two internally built fingerprinting libraries, one for SSL libraries and one for web app frameworks, JavaScript libraries, CSS libraries, all these different things. Fingerprinting is important because we want to understand what's in our ecosystem. We want to understand who is using what and what technology is being brought into our ecosystem. And it's also important for some cool vulnerability detection and threat intelligence, and I'm going to talk about that towards the end when we talk about future steps. So like I said, Heroku is what makes ZAP. Heroku is the ZAP at scale part of the title of this talk. We rely on Heroku for the scalability. We have dyno types for each major type of scanner or engine. And we have two dynos that oversee the entire system and pull it all together. They're going to handle auto-scaling logic so that we can scale up and down based on demand and based on budget. And then we have Heroku handling all of our operations. So servers dying, we don't worry about hardware. It's all abstracted. And what's great about that is that we can operate with the invariant of knowing what every scanner looks like. We can, if a problem happens that we don't know how to handle, we can literally just turn it off and back on again and see if that fixes it, because that's all you have to do with Heroku is tell it to shut down and come back up. On the other hand, we do have to ensure that jobs are self-contained and self-reliant and that they fail quietly, because we don't want one dyno going down to spiral out of control and take the entire system down. And we also don't want Heroku interfering. So Heroku has some invariants like requiring every dyno reboot every 24 hours and memory constraints. We want Chimera to handle that because we don't want Heroku sending sig terms or sigints in the middle of a scan. So we keep control within Chimera of that. We do some monitoring, so we shut down if there's no scan on a dyno after 16 hours of uptime. That way we know that when a scan starts, it's actually going to finish as opposed to Heroku killing it for us. The database that we're using, the persistent data store, is a Salesforce backing org, which I will admit is not your usual choice of a database. That said, there are some great libraries out there that let you abstract it and basically treat it like a Postgres database. The reason we're using it as a backing structure is because we want to be able to easily integrate with the rest of our ecosystem. Like I said, the entire point of this is to make it as easy as possible and make there be as few hoops to jump through to get security scanning going. So that's how we accomplish this. Redis is used for temporary fast access data. So once a job is started on Chimera, it's pulled out of the backing structure, it's put into Redis, and Redis keeps track of all the details of the job. So that's ephemeral. And then we use Redis queue on top of Redis to handle the short-term queues. So based on the number of dynos that we're using, we actually pull the jobs in from the persistent data store, and we store them in a Redis queue to actually get handled. And the reason we do this is because if something catastrophic happens and Chimera goes down, we only lose 10 or 12 scans at a time as opposed to losing our entire back queue. So this is what it actually looks like if you were in the backing structure. That's another advantage for us, is that because we went with a non-traditional backing structure and we used it, Salesforce, we have an easy-to-see UI for the scan information here. And while that's not necessarily important to URI, when we transition this to a internal DevOps or support team to handle support tickets, this is going to be very easy for them to just jump in and see a UI that basically represents everything ZAP or Nikto is doing. And as I said, there's quite a bit of custom code, and the auto login engine is part of that. We talked about it earlier. We use ZAP's HTTP sessions API to push all that data into ZAP and have it use it. And then we have those two dynos that manage everything. So we have a pulse dyno, which is essentially Chimera's heartbeat, and that keeps everything together, manages dyno health, it starts reboots, it also does auto scaling, and then we have a report generator that pulls together all of the scans output. ZAP, Nikto, Nmap, SSL lies, our fingerprinting tools, they all output in different ways, and that's not very helpful to the technical lead that's getting this data. So we want something actionable and that looks very consistent for them. And then we have custodian dynos that handle exceptions and escalations and analytics. So again, this is part of the custom code, and you can see there are two parts I want to highlight. Up here, you have dyno caps. So auto scaling is great because as we get more and more load, we can just add more and more dynos and do more and more scans at once, which is great and all, except that we don't have unlimited money. So what we do with dyno caps is you set a budget when you start, and then you allocate that budget to different types of dynos, the ZAP dyno, the Nikto dyno, whatever. And we will scale up to that. That's as high as we'll go. So you know you're not going to spend any more money on your Heroku bill than this. But as dynos are inactive, we will kill them and scale them down. So you may well spend less. But we do have a cap system here so that you don't go over at least a set maximum. Then you see here the jobs that are active. So we have a ZAP job active on our #1 ZAP dyno. And this is all data that's coming from Redis. So like I said, every dyno and every job has a blob in Redis that has all this data. You get to see how much memory the dyno is using, how long the dyno's been up, what progress ZAP is at. So we use the ZAP API to pull out job progress in a percentage, and we display it here. And this is just a great one-look dashboard that we can have up on a TV in the office and understand how much usage is going on with Chimera. Okay. So I have a rough architecture diagram, and I realize that this is not a good format to show an architecture diagram in, so this is going to be available with the materials. But essentially what's going on here is you have the backing org, data being pulled into Chimera on Heroku. All of Heroku is, or all of Chimera is distributing it to the different types of dynos based on the engine. Those dynos are attacking your target. The data is coming back here. When a job is done, it'll pass it on to a report generation dyno, and the report will get sent out. But how are we using ZAP? How are we making ZAP click online and in the cloud? If you look at the source code on my laptop, the parent folder is still called ZAP Cloud, because when we started this project, our entire idea was just to make ZAP available to anyone who wanted to use it without any training. And then we thought about adding more things to it. So let's talk about how we use ZAP and what we've learned by it and some of the things we've added in around it. So everything for Chimera except for the scanners themselves is written in Python. We use the ZAP Python API, and we use ZAP 2.3.1 right now. We're going to get up to 2.4 on the stack and the new Python API as soon as possible. We haven't spent the time to do that quite yet. So the ZAP jar and all of its related files and plugins are just part of our Heroku slug, and we actually only use plugins ascan, pscan, corlang, Spider Ajax, SQLi, and retire.js. We removed all the extra plugins because of our memory footprint. That's something that we really care about minimizing on Heroku. And this is really all we need to run ZAP in a headless mode and do the scans that we're trying to get done. And then we use the Heroku multi-build pack around it to ensure that we have all of the backing libraries like Java 7 on our Python-based dyno. So we start our ZAP jobs on a 2x dyno, which for those of you that are not aware of Heroku's constraints means 1 GB of RAM. And we start ZAP with the subprocess library from Python using a slightly modified zap.shell. We added a garbage collection flag because in our not so rigorous testing, it seemed to bring the memory footprint down a little bit. And we are using it in headless daemon mode and making all of our interactions via the API. So if I jump in here, you can see basically how any of you using headless ZAP would be starting it with Python. We just start up ZAP using subprocess right here, connect to it with the ZAP Python API, and then just start trying to connect to it. And if for some reason startup failed, if we can't connect to it after about half a minute, we just kick the dyno and start fresh. It's basically IT 101, turn it off and back on again and see if that fixes it. So as I said, we're starting on a 1 GB memory dyno. Not all jobs complete on that dyno. If you're scanning a big site or if ZAP encounters something that's using more memory, we do kill it, right? We kill the dyno so that we don't get shut down by Heroku, like I said earlier. But then we pass it off to a performance dyno with about 8 gigs of RAM and try it there. Now, we haven't yet run into something that fails on that dyno. Theoretically, if we did, we would just cancel the job and tell the user who requested it, hey, I'm sorry, we can't quite do this in the cloud yet. Here's how you download ZAP. Here's how you do it yourself. Now, I said we were using Redis-Q to handle all of our jobs. So we just use custom exceptions and throw them out there, and we know why a job stopped, and then we handle it appropriately. So Redis-Q really helps us out there because it can catch specific types of exceptions from within a job's code. So again, this is what escalations look like. Let's get out of here. So all we're doing here is checking memory usage from the ZAP dyno using a shell script, and we're checking job status with the ZAP API. And if it's over for too long, then we just bounce it out to another dyno. So the best way to interrupt an RQ job, as I said before, is throw an exception, and we catch exceptions for memory, for killing a job because something else failed, something we don't understand. We catch it if Heroku restarted a dyno without telling us. We catch that SIGINT or SIGTERM and throw it out to the RQ exception. And we also catch exceptions if we weren't able to verify ownership of a target. So now, a couple of things we've improved on ZAP that we've learned along the way. ZAP reports everything it finds, and that's not a knock against ZAP, but it can be confusing or overwhelming at times. Let's say that ZAP found X-frame content options header is missing, which is probably the vulnerability I've seen the most in all of my test ZAP reports. And it scanned 350 pages on the site, so now you have 350 instances of that vulnerability. Multiply this across a couple more vulnerabilities that affect every page, and you have a ZAP report that looks something like this when you're exporting it. So what we care about is the signal to noise ratio. We care about that report being representative, but also being very actionable as opposed to overwhelming. So what we've done is developed some vulnerability pruning, and the goal here is to reduce the number of issues reported to the end user per vulnerability class while not taking away from the representative nature of the report. So let's say we have this. We have scanme.com, and you can look at a user's profile. And if you look at 123, user ID 123, you are going to see the same thing, the same page essentially, but it's just going to be a different user. So I have here a tree where every node is a page and every edge is a URL separator. So I found vulnerabilities on all 4 pages, right? Not surprisingly, I found the same vulnerability on every user page because it's the same page, just displaying different data. So can I not have the same representativeness of these vulnerabilities with a report that gets rid of vulnerabilities on those 2 pages within the same class of vulnerability? I think that's pretty safe to say, right? If I show you the vulnerability on user/1 as the URL, and you go fix that vulnerability in the code, it's going to fix the vulnerability for user 2 and user 3 as well. So now I've removed 50% of the vulnerabilities, maintained the representative nature of the report, and I have a much higher signal to noise ratio for my report. It's not as overwhelming to a user, and it should be just as actionable. So we did implement it with a tree structure. The custom node at the leaf understands what issue ID from the ZAP API that leaf represents. So after we do a pretty standard prune on the tree, we just look at what IDs are still in the tree, and we only pull those IDs out of the ZAP API. So it was easiest for us to develop this as a Python layer on top of ZAP using the API. Our next plan is to contribute that back to ZAP in the reporting API, or the reporting part of ZAP. So we're going to find a way to convert our code to Java and give it back to ZAP so that an option in the report export options for ZAP will let you use this same vulnerability pruning. And we want to be giving back to the open source community, especially ZAP, as much as possible. The other fun thing that we've done with our reports is evidence trimming and highlighting. So if we have an evidence string from the ZAP API, we want to look through the request and response header and body. We want to find that string if it's in there, and then we want to trim around that string and highlight it. So it's going to look something like this in the report. We basically want to show you exactly why we think this vulnerability exists. That way, if it is a real vulnerability, you can jump right to where it is in your code, or right to where it is in the output, understand what we're thinking, or what ZAP is thinking. But if it's a false positive, you also know exactly why we flagged it, and that should speed up the process of saying, hey, it's a false positive, and telling us why. So I'm going to skip through this right now. I'm going to show you the report that was generated for Testfire right at the end of the presentation, but I only have a couple minutes left, and I want to get through some of the coolest stuff in my mind, which is what we're going to do next. So we really want this to be part of a secure development lifecycle. We want to transition to Chimera as the primary scanner prior to people entering our app ecosystem. And thanks to scalability, we want to encourage this as something that's used in the dev process. That improves security for us, it improves security for people writing apps in our ecosystem, and it improves security for everybody using the platform in the ecosystem. What really matters is the users being secure, not whose fault it is, right? So we want to then start to provide Chimera as a platform for periodic scans, and that's where the fingerprinting is going to come back in. With every scan Chimera does, we collect invaluable data about what's being used in our ecosystem. And that information we collect can be tied to a security point of contact that can help us resolve things. So the first thing that helps us does is thoughtfully direct security resources. If I see that a certain version of jQuery, for instance, is being used in 38% of the applications in my ecosystem, is it not worth a week of a security engineer's time to do a pen test on that library? That is a disparate impact. One security engineer doing 1 week of work is now finding a vulnerability that might affect almost 40% of things running in my ecosystem. That's how you maximize the impact of your product security team. The other thing that we can do now, we have this fingerprinting data being stored in a database. We can combine that with a live CVE feed. So we can see instantaneously when a new CVE comes out, what part of our ecosystem is vulnerable and how that is going to impact our users. And even more than that, we can do it over time. So if you use version 1 of a library, and then you upgrade to version 2 3 months later, and 3 months after that, a CVE comes out for version 1, if you're just looking at your stack, hey, I'm using version 2, the CVE doesn't affect me. But what we can tell you is that for 3 months you were vulnerable, and you do need to start incident response and see if you were affected, because we have this timestamp data that we can correlate with the timestamps from the CVE. That's basically going to be threat intelligence and the beginnings of incident response as a service. Now, there's really no reason in the traditional product security model that I should care about doing threat intelligence for people that don't work for me or work with me. But again, what really matters is that our users are secure. It doesn't matter whose fault it is. We can use this technology to make our users more secure, and that's all that matters. And finally, we want to give back. So we love ZAP. We use it constantly. We pass it out to all of the people in our ecosystem. So we want to start contributing back to ZAP, since it's open source. As we start providing this to more and more people, we expect to find edge cases, we expect to find bugs, and we expect to find things that we can improve on. So we want to pass that back to ZAP, contribute back to the community. As I said, we already want to contribute back some of those reporting API features, and we want to make it better for everybody. We also are looking into how we can use new features on Heroku to distribute this entire platform as a slug. So maybe one day when we're done with all this, or we've made enough progress on it, we can pass it out to any other company that wants to use it both internally on what you're working on, or on their own app platform. The conclusions I have is that, one, clearly ZAP is awesome. You're all here at an OWASP conference, so I'm going to assume you agree with me there. Cloud app ecosystems are going to become the primary way people interact with large online platforms. Your engineers aren't going to have to write everything. You rely on your app marketplace for that and your app ecosystem. Through the intelligent use of smart technology and smart automation, through data mining, through threat intelligence and analysis, large companies with a lot of product security resources can make the entire internet and the entire cloud more secure for everyone. And I think we can all agree that's a good thing. If we make the cloud more secure for everyone, it's going to make our jobs easier, it's going to make more people adopt the cloud, and it's going to make just basically everything better. So that's all I have. Thank you very much. If you want to get in touch with either myself or people on my team, you can use these Twitter handles or you can email me at that address. I'd be happy to take some questions now. Just please use the mic in the center so we can get everything recorded.
First, thanks for the talk. Have you talked to Simon about what he's doing with ZAST, the service as a service?
One of my colleagues actually went to AppSec Europe this year and talked to him at that conference. We do hope to contribute back to that or help in any way we can. We started our development before I heard about ZAP as a service, and it's going to be in parallel for a while, but I'm sure both of us will come up with things that are helpful to the other, and so hopefully, as I said, we can contribute back as much as possible.
Right. Thank you.
You may have mentioned this a little bit, but I was curious, for the reporting aspect, how do you, I guess, get rid of false positives or manage kind of what can be overwhelming from those kinds of reports?
So in terms of being overwhelming, we're trying to handle that with vulnerability pruning. We know that we're not going to get rid of false positives. That's just not possible. What we're looking at as a way to handle false positives, especially in the flow of a secure development lifecycle, is providing a cloud platform that they can see their report on. The same way you would go through static reports and maybe audit them, you can let us know you think it's a false positive and provide some evidence why. That'll come back to us. We haven't found a good way to eliminate false positives in general, so what we are trying to focus on is eliminating essentially the same vulnerability being reported hundreds of times and addressing that as a way to reduce the overwhelming factor.
I may have missed these details since I got here late, but if you haven't talked about scalability, like how do you make basically a standalone tool scale? I assume you are creating multiple instances.
So essentially, Heroku provides us a guarantee that every dyno is the exact same. We've tested this with up to 100 scanners running at once, and essentially it's 100 dynos. So all it takes for us to scale is to send the API command to Heroku to scale up a new ZAP dyno, and that's essentially a new scanner ready to go. So the only constraints to our scale is how much money we're willing to pay for essentially AWS space.
All right, and so for for basically exploring the app, it's the crawling part that ZAP has. Like you're not actually doing like proxying of the traffic as you would do.
We're not doing proxying of the traffic. For exploring the app, first we're going to use that tool I talked about to try and find a way to log in, pass that cookie jar back so ZAP has access to as much as possible. Then we're just going to do a normal ZAP spider. Okay. We are looking at some ways, though, I should add, to chunk up the spider results and split them into different scanners to increase scan time or decrease scan time.
So do you typically ask developers to run your ZAP as a service against their production environment or a development environment?
I would recommend a development environment, of course. One of the other things we see from people with less resources and less experience is sometimes they only have one environment. So we do try and we don't try and use destructive tools as much as possible, and we always suggest they give us a standalone environment, but we have definitely run it on production environments. Great. Thanks, guys. Feel free to email me if you have any other questions, and be happy to connect.